All right. Well, I guess we're live, hopefully. So welcome to the very first MathJax Hangout on air. Um, my name is Peter Krautsberger. I work for MathJax. And with me I have Christian Perfect and Phil Schatz. Do you want to say hi?
Hello, I'm Phil Schatz.
Hello.
Yeah.
All right. So basically, I just wanted to take the opportunity to meet up online with two awesome people and talk a little bit about MathJax, about how it's used in your projects, and whatever else comes up. We should have a Q&A up in the event. Since this is the first time, we're not quite really sure. I'm not quite really sure how this works. So I hope people will be able to actually ask questions that way and find this on our Google Plus stream on the MathJax page. All right, so maybe just hit it off, and maybe you two can say a little bit about the projects you've been involved with, that in particular those that feature MathJax. Whoever wants to go first.
Sure, I can go. So again, I'm Philip Schatz. I work for a nonprofit called Connections, and we make Creative Commons licensed textbooks for community colleges, high schools, universities around the world. And we use MathJax in a couple of ways. And so we use it, our content is stored in a structured markup language with MathML, and we use MathJax to render it on the website for people to look at. We use it in our editor that we're using for where you can edit tech or ASCII math and have it save into MathML. And I'm also looking at getting MathJax rendering on the web server in order to support more accessible MathJax. So using both MathJax, Node.js, and tools like Chromevox to do text-to-speech. That's me.
That's awesome. Over to you, Christian.
I'm Christian Perfect. I work at Newcastle University in the UK, and the main part of my job is to create a system called Numbers, which we use for e-assessment, these weekly homeworks for our undergrad students to do. The main thing that makes it different from other e-assessment systems for maths is that it runs completely in the browser, and it's all written in JavaScript. So they all get randomized questions and things like that. And it uses MathJax quite heavily for display of maths stuff that's in the questions, and also rendering what the student has entered. And I also do a load of fiddling around with MathJax in other places, like getting it on your blog or tools to make it easier to use, that kind of thing.
Yeah, we love those. All right, awesome. So we had at least a technical confirmation from Vincent Knight that the Q&A works, so that's great. So feel free to ask. There is a question, is that, I'm guessing that's addressed at you, Christian, but it just asks Android or iOS, so I'm not quite sure.
I can't see this question.
Oh, you cannot see the question? Can you hit the Q&A app on the menu? I don't know if that even makes sense to do it, but
I can see one that says Android or iOS.
Right. Maybe the Adam can ask something in more detail.
So actually, I'm wondering, Christian, the assessment tools that you write, are they? You said that they run on JavaScript.
Yep.
Do they run on JavaScript on mobile devices as well?
Yeah. I've tried to stick with standards wherever possible, so it runs on just about everything we've tried it on. Quite a few of the students a few of the students do their homeworks on their iPhones without us telling them they can do it. Every now and then they complain that something breaks, and they say, "Is it maybe because I'm using it on my iPhone?" They say, "Well, no. But why are you? It's really hard to type on an iPhone." So, yeah, it works with just about everything.
So actually, along those lines, so my understanding is that the students end up writing tech as solutions for homework assignments. Is that correct? Or
Well, it's not quite tech. It's the kind of thing you'd write in a calculator, then that gets parsed and converted into tech for display.
So is it more like ASCII math, or is it something stronger?
I haven't used ASCII math too much, but it's getting on that way. It's really is just like BASIC or C, that kind of thing, where operators are binary, functions have a name followed by some brackets. The syntax isn't very complicated at all.
That's awesome. Why?
Oh, and that the library that does all that I've just released as open source as a standalone thing last week, which I can give a link to later on.
Okay. Is there actually a way to post comments in here?
I think the way it works is you select a question and then it says that you're currently talking about it, so that I'm guessing in the video stream it will show up.
I see.
And then you can, it's just as an example, let's select this one, and then it sort of moves to the top, and then once you're actually answering it, you can say done, and it's answered. So I think the answer to Android or iOS, at least for numbers, is that yeah, it works in both. Even though it's surprising that people actually start authoring there, which is a bit of a challenge. But I guess tools are coming, so maybe it's less of a challenge than we think.
Mm-hmm.
Have any of your students used handwriting recognition? Like MathPad, that kind of thing on iOS?
No, and I don't think it would work because.
Oh yeah, because you're not. Yeah, you need text. Yeah, you can't use
input.
text. Yeah, sure. Sorry. But the language sounds really interesting. I would love to.
Yeah, well, I can paste a link to the library in the chat. That would help. Let's go and find it. Okay, here's the library that does maths parsing, provides a load of mathematical functions. It's got a stupid name because everything has to end in JS, and the only mathematical word I could think of ends in JS-ish is liturgy. So it's called lisp.js, which doesn't really work. And the e-assessment system is called numbers. And I can give a demo of that later on if we reach a quiet moment.
All right. Should I, in the meantime, take over this question from Vincent?
Sure.
All right. So I hope this is now in the stream, but just in case, I'll read it out. Vincent Knight is asking to hear a bit more about WordPress and why MathJax is so ugly on WordPress. I'm not quite sure I understand, in the sense that I'm guessing you're referring to WordPress.com. I hope. In that case, the answer is there is no MathJax being used on WordPress.com, but instead, basically a similar solution to to the well-established old ones. It simply uses LaTeX in the backend to generate images, so you don't actually see any real MathML or proper HTML, CSS rendering like MathJax does. You just see a static image, and that's what makes it, in my eyes at least, pretty ugly. If you have your own WordPress installation, you can actually install alternative plugins that will hook in MathJax, and so you get the same kind of rendering that you would expect from a MathJax site. And even if you're Christian perfect, then you just write yourself a little bookmarklet to replace the images on the fly. So you can, at least when you visit WordPress.com as a reader, you can improve the rendering by just having MathJax, as a user decision, as a reader decision, you activate MathJax to replace the images on the fly. And that is usually a very nice experience. Maybe we can show that off. Do you have a bookmarklet ready, Christian?
I have a bookmarklet. I'm not sure if it's the one that places stuff on WordPress.
All right.
We'll give it a go.
I was curious, does it use the alt text on images, or do you parse the...
Yeah, the title or the alt text. I don't remember which one is used on WordPress.
Cool.
there's another attribute as well, it's called like data latex, I think, which sometimes is used.
All right, at least Vincent is telling us that we're answering his question. That's good. I'm glad we could clear that up. We wish they would switch over. We have tried. I mean, we at MathJax have tried to reach out to the Jetpack team and talk to them about it. But ultimately, of course, it's their decision. So if you want to improve things on WordPress.com, you really have to talk to Automatic, the company behind WordPress and WordPress.com.
And it's quite annoying as well because many of the like Tim Gowers and John Byers, people like that, are still on WordPress.com for some reason, despite it being quite easy to set up your own installation of WordPress. So they're all still using the old blurry maths. Yeah. Right.
All right. I'll see if I can cook up a bookmark that I should have it somewhere. And in the meantime, I'll answer this. Consider this question answered, and maybe Christian, if you can share something on numbers, that'd be great.
Yeah. Oh, you want me to do a screen share?
Yeah. Just show it off a little.
Right. Okay. So my screen should now be taking up everyone's full view. So this is the numbers editing interface. This is the publicly available version at mathscentre.ac.uk. It's got a pretty big bank of questions and exams. I set off this demo exam a while ago, which I'll do here.
So I'm curious, is that a public question bank?
Yeah.
Cool.
That's pretty awesome.
We realised that the main use of computer assessment of maths is not for real points at university, because you can't really ask very in-depth questions about maths that a computer can mark. It's mainly just for practicing methods and techniques, like kind of drills on factorizing and integrating stuff that you want students to do 100 times. So there's not much to lose in making the questions available to the public. Like if a student sees the question and sees in advance how to solve it, that's good. Anyway, so yeah, this is what a numbers exam looks like. We've got a question here. MathJax is being used to render some math notation in the statement, but then you're also asked to enter an algebraic expression as your answer. So I've got no idea what this is going to be. It's going to be 3x minus 24. And as you type, you get a rendering in MathJax of how your answer has been interpreted. So, I don't know. Some x minus 9 there. So did I say this on air or off air that the syntax there is it's not LaTeX, it's not MathML or anything. It's this really simplified, basic syntax. And the really good thing about MathJax here is that it lets us have this instant preview without having to press a button to render something or send off to a server to get an image back, which is how systems have done it in the past. And that's really slow, and it's pretty bad from a usability point of view. Students find this really helpful to check that they haven't made an error, like if I put x minus 8 there, that'll multiply the whole lot by x minus 8, even though it looks over here in my input, I might have wanted both of these things to be on the bottom of the fraction, so I can see that I need to put some more brackets around there. Is there anything more we want to know about numbers from a MathJax point of view?
So I was curious, since you use your own language, how do you, and since it's not LaTeX or ASCII math, did you end up having to write your own plugin for MathJax to convert it, or?
Yeah, well, I've had to write, because all this stuff's running in JavaScript in the browser, I've had to write the beginnings of a computer algebra system from scratch. So there's a parser which parses this stuff into a syntax tree, and then other functions which turn that into LaTeX for display, other functions which evaluate it for marking purposes. Yeah, so I've had to write a lot of code for dealing with maths.
Okay.
That's pretty cool, I must say. I would love to, yeah, we should definitely see, well, I would definitely love to see that syntax more widely available.
And yeah, I really like the live preview. So.
Yeah. Yeah, so recently quite a few people have asked me about that, which is what prompted me to take all that code and bundle it up as a standalone thing, separate from the assessment system. And that's the first link I posted into the chat before, the Lissa.js library. And that will do parsing of this syntax there, render it into LaTeX. It can simplify expressions, or really rearrange them is the preferred word. So if you've got a randomly generated expression or something generated by a computer, it can put it into a more natural form.
Was it for numbers with the backend? What are you using on the backend?
Well, numbers tests are packaged up as SCORM packages, which is a fairly widely used standard for assessment. That ties into any VLE like Blackboard or Moodle, and several of the newer ones use it as well. So that stuff takes care of all of the stuff like score tracking and session storage, that kind of thing.
That's awesome.
Cool. And so actually, I'm curious how much. So we've looked into using IMS packages and other packaging formats. How difficult is it to put the exercises and sort of the algebraic parts that you need to compute inside the SCORM package?
Well, the way SCORM works is you give an HTML file, which then just loads as a web page, and then included in the package. You include your JavaScript files and everything inside that package.
Okay.
And then it gives quite a wide variety of types of question. You report at the beginning of the session what kind of questions you've got, what kind of answers they expect to have. The maths ones, I just say it's a text answer, and that lets you record a representative of a correct answer you would mark, an answer you would mark correct, and also the student's answer and how many marks you awarded for it. So, yeah, it's nice and versatile in just letting you have this generic answer type that you can use for maths questions.
Got it. Okay. So, out of curiosity, what output format do you use for MathJax? Do you use the HTML, CSS, or?
Yeah.
Okay.
I don't think the way we load it goes very far to force it into HTML, but that's the one used by default.
Okay. Got it. And actually, so in terms of packaging, how do you include MathJax in there? Do you use the CDN version, or do you package MathJax into the HTML file? Or?
Oh, MathJax is about 20 megs, isn't it? So
Right.
that's not a good idea. For the tests that our students use, we have a copy hosted at Newcastle. So we assume that if they can get access to our Moodle server, they can also access our installation of MathJax, which is on the same server. But for the public version, we just load it off the CDN.
Okay. Cool.
Right. I mean, yeah, we've actually even grown now. So right now, I think 2.3 will be more around 50 megabytes.
Right. Oh, is that with all the extra fonts?
Yeah, this is simply because of the fonts. So if you know what you want, you will be able to still slim it down to. I mean, certainly if you wanted to, just use the Tech fonts, our own MathJax Tech-derived fonts, then you can still slim it down to 2 megabytes uncompressed, so including the fonts. But yeah, the fonts are costing a lot of space, and especially the picture fonts are usually what takes up even more space on the disk. So usually the 23 megabytes will take up 100 megabytes on the disk because of all the 1 kilobyte PNGs.
When I first started developing numbers and started using MathJax, I did all my work off USB key because I would move between work and home. We hadn't got into using Git yet. So every time I made a new copy of the software, I copied over MathJax again. There's 20 megabytes going onto a really old, slow USB key. I lost many. It was 20 minutes exactly each time. So I got quite adept in cutting out all the useless stuff.
Yeah, it's even worse when you do something like an FTP upload and you can't unzip on the server or something, and then you start, uploading 20,000 files of 1 kilobyte size. A lot of fun. Yeah. All right, cool. Maybe we should switch over to Phil and talk a little bit about stuff.
So I can. I actually have some questions that I think might be interesting. And we can get back to them after, but should I mention them now?
No, go ahead. Sorry, I was just...
Okay. So some things I've been wondering. So GitHub and Jekyll, I know that they used to, at some point, support math using MathJax. Do you know?
So GitHub, you mean not Jekyll? I mean Jekyll always supposed. I mean the GitHub pages, of course, you can load MathJax. The wiki used to support MathJax. Gollum is it?
Gollum, not Jekyll.
Right?
Yes.
Gollum is the wiki that they use, and the software itself still has a plugin or a module or whatever it is, an option to activate MathJax, but the site itself does not right now. And that's been, I don't know. There's been a lot of people that have asked on the relevant issue thread what the problems are, and I can't really say more, other than people have been asking. But I do know that GitHub has recently hired a new person who is sort of a scientist's liaison person out of Zooniverse, the excellent citizen science project. And so there might still be hope that they will reactivate it, and we are certainly trying to talk to them. And I actually am going to talk to that person soon, so we'll see if we can get around the problems that they've had. It's clear that they used to use it, then they ran into some problems, or did some evaluation of their JavaScript technology, and they kicked it out. And this might have to. I don't really know what it is about. I'm guessing it might have to do with content security policies, and policy and stuff like that. And we'll just see if we can figure it out.
Okay, cool. The other part, I wanted to say that. So we've started using, and including MathJax, we started using the Bower install of MathJax, and that's worked surprisingly well. And so I find that I found that to be a useful way to add MathJax into new types of projects that people are creating. So.
Can you say a little bit more about Bower, just sort of the technology?
Yeah. Sorry, sure. So Bower is a JavaScript package manager that you can use to pull in third-party libraries like jQuery or just third-party JavaScript libraries that you plan on including in your project. Sort of like the Node package manager or PyPy, but for browser libraries. And I think that MathJax recently released, I think from someone's contribution.
Yeah, we had a great contributor who simply, wrote up the package because we had not, really known about Bower before that, and so somebody just, made a pull request, gave us the right file, and that was it. It's wonderful. It's going to be in 2.3, and that should hopefully simplify that, for people.
Right, and I'm hopeful, or I'm hoping, and maybe I'll contribute, but having ways to slim down MathJax.
Exactly. Yeah. That's.
Right, yeah. All the files are there.
So there are some things that we're planning on our end. So, we do hope to retire the picture fonts in the sense that we will probably move them into an extension rather than, leave it in the core, and that will make it easier to then maybe, push the extensions into their own repository or make it easier to actually, for people to understand what they can and cannot remove.
Oh, I see.
And so, after all, they are thankfully not needed anymore. The picture fonts were really, for the time, those are things that David came up with David Savan, our lead developer, almost 10 years ago, I guess. He created them because there were no web fonts. The technology didn't exist. So the only way to do it was to have these, picture fonts, which had a character for every picture for every character.
Right. Okay.
So it's time to phase them out. Definitely.
Cool. And this might be a bigger discussion, but something something we chatted about recently, which was looking at instead of trying to, or in addition to trying to get browsers to support MathJax natively, there are lots of, or there are
you mean MathML?
Or MathML, not MathJax natively. Yes. In order to support MathML natively, there are certain features that that aren't defined in CSS, or that you can't describe in CSS, but might be useful for things other than MathML. And so,
what?
Sorry.
Oh, you mean things like the enclosed notations?
Right. So enclosed notation,
right.
I think, is the major reason that math does. Yeah, that you can't render math using just CSS. So, I'd be interested in
a few more, but yeah, no. Yeah. I mean, it's one of those things where you go, where you look at the spec and you immediately say, why isn't that in CSS? Why?
Right.
Well,
but I think that's
and first of all, CSS do it. Yeah.
Right. I think that's an interesting approach.
Oh, you mean that as what is the question?
Sorry. Well, so I guess it wasn't so much a question. I guess I wanted to say that I'm interested, and I think more people might be interested in looking at CSS modules. So writing a module that describes the types of features that you need, or that you would need to render math natively without actually supporting the math elements.
Right. Yeah, I think that's a big thing. I mean, certainly, should we talk about the whole Chromium thing?
No.
I don't really want to go there. I mean, it was such a, it was blown out of proportions a little. But, that's, even ignoring that, but just, yes, I think so. I mean, personally, I think so. But it's tricky because, because there are two sides to the story, right? I mean, first of all, you have to get the math working group on board for that kind of thing, and then you need to actually convince the CSS working group, which is a large and illustrious body, and then you still have to, I guess, work with the what working group and convince the actual browser vendors that this is a good idea. But I think that is, I think there is a lot of potential in thinking about how can I say this? The general potential of MathML, which is simply to improve typesetting, which has nothing to do with mathematics, as you point out. These kind of enclosing elements, which are elements in MathML, but should really be CSS properties when you're in HTML, CSS. These are some things that browsers don't have, that CSS doesn't have, and it's really something that could improve the overall situation for typography on the web, and that's something that's, I think, very important to point out, and often the browser people can't, there's lots to do. I have no reason to blame anyone anywhere, but they just have to, we have to communicate that better.
Yep, agreed. And yeah, so, right, that was most of what I had.
All right, shall we take a look at some of the connection stuff?
I'll go through, let me...
Awesome.
Try and see if I can find some examples. So let me try and find a piece of content on connections. I unfortunately did not prepare this one.
Do you want us to chat in the meantime?
No. I've got it. I'll share. Let's see. How do I do screen sharing again?
In the meantime, I can say, people ask questions, just interject. We're not going to. I didn't plan on, having gaps for questions. So if you just jump in and ask us something, either on what we're discussing right now or something unrelated, that's perfectly fine. We can organize the questions as they come in.
Sure. Okay. So I'll mention one of our recent books that we put in is a physics book, and I just opened up on cnx.org one of the pieces of content, just showing off how we use MathJax in here to render our books. The other bit, and so yeah, we use it throughout our site.
So can you say a little bit about connections and how it works and what sort of
oh yeah, sure.
How it's different from other authoring systems, in a certain sense.
Yep. Okay. So connections we're an open source project, and all of our content is CC BY, which has the interesting property that you can reuse parts of our content in other books. And so you can make a book that is tailored to your state or your school. And that's a feature that, because of licensing, it's a feature that you can do with these types of books. And so what we do is we provide some of the technology to make sure that you can remix parts of different books together and still provide all the proper attribution from sources. You can do things like derive copies of content and make your own edits. Yeah, so that's connections. And so several of our books end up getting reused and remixed in other ways. So this is a physics book that has some of the math. For example, a previous physics book that we have ended up being combined with a music theory book. And so there was a professor that wanted to teach physics, or teach the physics of music theory. So teaching music theory for physics students. So it was, yeah, pretty cool. So right, so we have content that's chunked up into small pieces and then remixed. And so one thing that we've been working on recently is an editor a newer editor to go through and do more of a WYSIWYG of editing of books. So here's an example of one part of one of our books, and in it you can drag pieces around, move them into other books. I won't do that because I don't want too many things to blow up at once. But inside the editor, you have like a canvas where you can type in content, and what I will do is show off some of the examples where we use MathJax in the editor. So for starters, we can type in a formula using ASCII math, and as you type, it updates on the fly if I don't change my tab. All right. Okay, and you can choose between ASCII math or LaTeX. And then once this is saved, it ends up being saved as MathML, which is what we use for generating our ebooks and PDFs and everything else. Some other interesting features of this is that you can take the math, you can copy it. And so if I include this in a paragraph, I can just highlight and then press Control-C, go down, press Control-V, and voila, my math is back there, editable and whatnot.
That's very nice. I like that feature. I must say. This is just, copy and paste, even though, it should be there, it too often isn't, and
right.
And
yep.
It's just absolutely cool.
And so you can also drop in exercises, right? Copy it and paste it, But yeah, so there's multiple ways. But yeah,
So I need to ask something. Will it work across books eventually?
Right. Good question. So if you, there are two ways that we go around this.
Two tabs open, and two editor instances or whatever.
I can try it. I'm pretty sure it does work. So for a bit more technical example, oh right. So the editor, for what it's worth, is hosted on GitHub. So the actual editor is hosted on GH Pages. It doesn't require a special web server. All you need is a GH Pages branch. But yeah, so I'll copy it here and see if I can paste it in here. Oh, nope, I copied the URL.
Of course.
Recopy this. And voila. Right.
Awesome.
So yes, there's some tricks that we used to get around and do it. I'd be happy to share, but we're open source, so you can go look.
Hey Phil, did you see let me select the question. That is a good question. How can we share a link?
So I just pasted the link in the chat. I just saw that a few seconds ago.
Sure.
All right. Well, I don't know if the group chat is visible on the live.
Oh,
so
right. I better stop.
Let me see if I can do this. Should be somewhere, shouldn't it?
It's odd that you can post questions, but you can't write answers.
Yeah, I think. Well, supposedly you're giving the answers, but I guess this becomes tricky with text. I can definitely paste it in the. Let me grab the chat. I can paste it in the event. I hope that helps. So now I've tried to paste it into the event post on Google+. I don't know if that helps, actually. Tim, can you say, Tim Arnold, can you say if you see the link, or am I doing it wrong? I mean, we can also read it out, I guess. It's oerpub.github.io/github-book editor.
Yep.
All right, Mark, thanks. I'll consider it answered thanks to a second user. Awesome.
Mark
Grover.
Oh, okay.
Who I only know virtually, but if you have Moodle questions, he's probably your guy.
And yeah, the code is, you can transmogrify the URL to the editor to find the code.
Awesome.
Yeah.
By the way, how did the work out of the Books and Browser hackathon?
Oh,
did you
right.
get to push that?
I can show that off as well. So for the demo
awesome.
book that I'm editing right now, you can go to, I'll point to, am I still sharing?
No, you're not.
Ah.
I know, well, you're sharing a video.
I am? Oh, well, but not screen sharing. Let me re-enable screen sharing.
Yeah.
So I think this is it. Right, yes. So I need a better example. So as you make changes, the default branch that you edit, if the default branch you edit is gh-pages, then the GitHub will automatically update the website, so you can go and view books. Where did I put it? Oh, Phil Schatz /EPUB.
Oh, that's very nice. So you're using GitHub repositories to store the book, and the finished version on the Get Pages branch.
Right. And so, sorry, this is a different book, but
Right. Yeah.
but yeah, you use GH Pages to host the book with a little reader, which we picked up. There was a sprint in, oh, I should not do that. So there was a sprint at Books and Browsers that Peter and I were at, and we worked on getting MathJax in the editor and getting it out on the, getting a reader to work with a tool called Hypothesis, which is a annotation service, another open source annotation service that you can use to annotate your books. And so it's hosted on GitHub. The book that you edit is an ebook and in a format called EPUB. And so you can download the zip, you can create a PDF from it. There's a continuous integration service at pdf.oerpub.org that listens to commits and generates a PDF whenever you change your files as well. So you have a pretty big build stack.
That's pretty impressive. Yes. How do you generate the PDF? Out of curiosity.
Right. So the PDF currently, the quickest and easiest way was to use a commercial tool called PrintsXML to create it. There's I've been looking at using Chrome. So with Chrome, you can start up a copy of Chrome and then press Control-P and save the PDF. And so that has the advantage that you can run MathJax, right? And then the rendered math that you have in your book is rendered the same. So that ties into the server-side MathJax stuff.
That's what we do with numbers. There's another way of numbers where you can produce printable worksheets for students. And the method for that is just to produce a page and then load it in Chrome and press Control-P.
Mm-hmm.
Using exactly the same trick.
Yep, it works pretty well. And so far, for what it's worth, the couple of features that don't work are things like page headers, which we need for textbooks. There's some CSS3 modules that we use, like target counters and target text for looking up when you have a reference that says see figure 4.3, right, you can look up. But there are open source projects that emulate that. I have a link to, there's one that I'm working on. So, but yeah, I would like to get away from closed source tools.
Right. All right. But by the way, just a shout out to Bob Matthews, who was kind enough to paste the link in the answers, so I could put it up. Thanks.
Oh, cool.
But I hear that people also exchange directly, so I think it's all good. All right.
So I think it's pretty cool that you have two people here, and both projects use sort of a live editing for math entry. And I remember that we had to jump through a couple of hoops in order to get that to work. And I'm actually wondering, I'm going to take a look at your Lissa.js to see if it's small enough that we could replace ours.
All right.
The previewing piece, but yep.
Christian, what do you actually use on your editing side? I mean, is it just a content editable?
Yeah, well, no, I'm not happy with the thing. I'll start my screen share up again and show you. I haven't found a good solution yet. I'm quite impressed with the connections one, actually. If I go back to that and edit and examine numbers, this here is a TinyMCE box. Sadly, TinyMCE is still the best thing for a WYSIWYG editor in a web page, as far as I can tell. There are quite a few new projects that try to cover things, but they're often missing a few features or take over control of certain things on the page in an annoying way. So I've got some text there, but then once I start writing maths, there's something which picks up where the cursor is and gives you a preview of that in a box that's just above, which is all right when you're not writing too much, but if you try and write something really long, a really long align environment, or something that goes across a few lines, it becomes quite unwieldy. I could probably dig some up if I went looking for the right questions in the database.
When you say unwieldy, do you mean MathJax is running into trouble, or is it just the entire environment?
It starts taking longer than the gap between key presses to render the maths, which is sort of alright. You can say only re-render it twice a second or something like that. But then just this preview box becomes very big.
Right.
And can end up taking over a lot of the page, and it's hard with just CSS to get it to position so that it doesn't go over what you're trying to write on. So yeah, it's not ideal. Really, I've strayed away from the thing where you have some maths inside the text that looks like maths, and then you click on it to edit it, because it's still quite nice to be able to edit maths in line as if it was LaTeX. If you get what I mean there.
Yep, agreed. It's much easier to copy and paste it, like if you have a notepad that you work on.
So because lots of these things would cause you headaches, I just went with this, which was a sort of nice intermediate step between writing LaTeX and having to compile the exam in order to see how it looks, or on the other hand, dealing with it purely in a even having like drag and drop symbols editor thing that people seem to like, which I think is far too slow. Yeah, and this code that does this actually runs. I wrote it so it will run in any text area. And on my blog, whenever you write a comment, you can start writing LaTeX and you get this preview thing. I've forgotten how I released that. It may be as it's called Write Maths. It's in my GitHub page somewhere. Yeah, you'll find it.
So I was looking a little bit. The editor that we use is called Aloha, and it does content editable. And I recently heard that TinyMCE4 now uses the content editable attribute instead of making an iframe. So that might be worth looking into. That way you don't have to. Yeah.
Right.
Yeah, that's interesting. Yeah, I'll have to have a look at that.
I mean, it's worth pointing out what what some of the work related to the OER pub. I mean, from Kathy Fletcher, right? She had written a couple of blog posts about the experience of actually exposing it's not the book editor, right? It's the OER pub editor is slightly different again. Am I getting that right, Phil?
They're all about the same.
Right, they're roughly the same. But yours doesn't have the? Do they still do that? The sort of cheat sheet for frequently used formulas?
So yeah, we removed the cheat sheet for a little bit, and it's not in the GH Pages branch.
Right.
But we have a little cheat sheet on the bottom that you can click to add in formulas, and she found that to be quite useful.
Right, exactly. I mean, generally, her experience describing how teachers in South Africa were actually able to pick up a LaTeX syntax very easily, just because they had the immediate feedback loop and they had the samples to just get going and get starting writing content. It's really surprising to me because LaTeX is pretty obscure technology, really. I mean, outside mathematicians and some sciences, there's really not much immediacy for that kind of syntax, and so it's fascinating to see that it's not hard to pick up. But I think it's also equally interesting to have something like ASCII Math and know what Christian has done. I think we we really need more of those, in a certain sense. Just
Right.
explore.
So actually, one thing that I really like about MathJax and its support for ASCII Math and LaTeX is that you can start off easy by having something simple like ASCII Math, and then if you need to write more elaborate formulas, then you learn the additional markup and switch over to LaTeX. Yep.
Yeah, there was just this week there was a somebody showing up on the user group asking for a simplified LaTeX syntax, and I think it is an interesting challenge. I mean, personally, I feel we very much need something like ASCII Math, but maybe a little bit more polished, because Peter Chipson never got around to sort of doing another's go and fixing some of the issues that it has, and just sort of, I like to say, a markdown of mathematics, something that is not totally powerful, but gives you the basics, and then maybe is structured in, has a similar structure like Markdown, where you can fall back to HTML if you need something more complex. You can just, use that, and it will work fine. That kind of structure. ASCII Math is a lot like that, because you can sort of, you can use a LaTeX-like syntax, and then you can fall back to more complex LaTeX. But we're sort of not there yet. There is JQ Math, which is interesting, which has its own serialized syntax and is more of a serialization of MathML rather than trying to be an implementation of LaTeX. But so it has, it has little things for M-unders and M-overs and so forth. And maybe, of course, the ideal thing would be something where you can extend to MathML and extend to text, if you need more. But we're just getting started, I suppose.
I saw that.
Math hasn't been around that long, really.
I saw that emails and mailing list a while ago, and I decided there are a few of the points on there. Oh, they'll be quite easy to do. I can just write a function that will. A few of these things that I was asking for, you could basically do a string replace on some text and turn it into LaTeX. But then I realized there's something, automatic detection of align environments, and that would be very nice. Like, the idea was, rather than saying begin align, then a load of equations, end align, just to recognize you've got a few equations next to each other with ampersands next to the equal sign. But then at that point, I realized that LaTeX grammar is really, really simple. It's got macros start with slash and then a name, which is just some letters. Use braces that enclose things so that they all get the same macro applied to them, and that's basically it. And then what the other stuff, like ASCII MathML, does is it makes the grammar more complicated, but the syntax less. I prefer LaTeX because the grammar is simple, so you can say whatever it is you want to say. It's just going to require quite a few key presses and maybe an obscure command. But then things like ASCII MathML, they're easier to get going with, but then they have all these weird edge cases where the syntax doesn't work, and you really just there's no way of expressing a particular thing. So after that revelation, I realized it wasn't worth me writing this parser for the LaTeX thing this person asked for. I'm not really sure I've seen a better compromise for that than LaTeX. I think it's hard to learn at first, but the basics of it, enough to get sort of elementary arithmetic stuff down and equations, will take you an afternoon. And
I guess I wish we could get I mean, this is getting off topic, but I wish we could eliminate some of the more baroque features of its syntax. Right? There's just some things that are just, I don't know. But you're right. Maybe I mean, certainly it doesn't matter much in the reality of things, but we'll see.
And so I will say I'm glad that that MathJax supports both, and that it seems like that humans are able to pattern match, and given things like templates, they can get through. But yeah. I think we all agree that writing MathML is not the way to go.
Right. I mean, that's yeah, but that is just a common misconception. I mean, do you really want to write a complex nested set of tables in HTML? I think
No.
most people won't do that either. And nobody complains about the table tags.
Right.
It's just, and and most people won't write SVG by hand either, even though some people do. Some people used to write PostScript by hand. And that's, there's always someone, but yeah, that's of course a common. I mean, that's brings us back to the big discussions about. I mean, last week with all the fuss about Chromium, a lot of that came up again. I don't know how much you followed it, but it's just people just bring it up again and again, and they just don't really know what the point is, or let alone have tried to create an alternative.
Mm-hmm.
I really like the argument that basically, I got from the math working group people that this is, essentially what MathML is trying to, start with the existing syntaxes that people knew, and LaTeX was, of course, one of the dominant ones, and then try to put that in a DOM, and that's just what you need to do, and you end up with a similar structure no matter what. I mean, LaTeX math, of course, not LaTeX.
Agreed.
But, I'm not saying it's perfect. I'm just saying, it's MathML 3, and HTML3 wasn't perfect, and 4 and 5 aren't perfect either. So.
Right.
All right. So, I guess are there a couple of questions? Most of them aren't. I haven't really had time to look.
It's an interesting one.
Thanks. So other people have provided the links again and again.
So I had a SVG question since you brought it up, but.
Ooh, okay.
So in working on the server side SVG or using MathJax server side, one of the output formats that I liked was SVG, and I'm wondering, are there plans to right now? The SVG is drawn as a series of paths, and now that you have fonts, or since you have fonts, are there plans to have an option to replace the paths with fonts? And so it's interesting for us.
Yeah.
It's interesting
for us.
It's a very
interesting question, yeah. I've been thinking about this as well. I guess probably because you brought it up. But yeah, so right now, the whole point of the SVG output at the time was not to use fonts. Because if you tried to use fonts, you would have to basically, so originally the idea for the SVG output was speed improvements. And then, this was all between 1.1 and 2.0, right? The SVG output was introduced with MathJax 2.0. And 1.1 was, much slower. People complain about the performance of MathJax, but just give 1.1 a try, and you'll be happy to switch to 2.0. And the SVG was, the initial idea was that this might be a faster output. And in fact, it is faster. It still is a little bit faster than the HTML output. But then at the same time, David found lots of ways to improve the general HTML output as well. And so they ended up being not that different. And so part of that was, the big problem for MathJax is to correctly calculate the placements of the letters. And there's some problem with basically internally calculating the widths and then the browser laying out the fonts and the characters and then doing kerning and subpixel rendering, and then suddenly your width isn't accurate anymore. Your internally calculated width isn't corresponding to what is actually the width. And so you have to basically measure that again, and this is computationally intensive. You have to do layout, which you shouldn't do, and so forth. And so the idea was, let's get rid of that, because in SVG you didn't have to, the browser actually did what you told it to do. That's basically the advantage of the SVG output, speed-wise. And so that was why there were actually paths and not fonts, because characters. Because if we used characters, we would have had to do the same thing as we do in the HTML output.
So I'm curious though, if you restricted the fonts if you loaded the fonts, then you knew the glyph sizes beforehand, and whatever the kerning options might be.
Well, okay, now you're getting out of my depth.
Or no,
Yeah.
Isn't the problem that SVG won't let you use web fonts? I thought that was the
No, it's really the treatment of really character strings compared to the treatment of SVG. It's just different, the way it's rendered by the browser. I mean, unsurprisingly, it's a completely different renderer within the browser.
Yeah. But if you have a text element inside an SVG image in a browser, there are quite a few restrictions on what that can be.
Right.
I think.
But I think that wouldn't be so much. Well, anyway, so get back to. Let me get back, because now I'm out of my depth. So maybe David can afterwards say something more detailed. But to answer Phil's question, I have been thinking that when we, improve the server-side rendering abilities, that this might actually be something to do. To actually not just create the SVG output the way we create it, but maybe create an SVG output that actually uses characters instead of paths. Because then, it's not about the performance so much.
And you can, for us, you can embed fonts inside PDFs, and only the glyphs that you use. Anyway.
Yeah. I mean, this is the one disadvantage, right? That you described in the hackathon, that the files get huge, right? And of course, on the web, we actually work around that with the SVG output by providing, by reusing the paths out of a global file, which is basically the same as an SVG font file. It's just has a different shape. And so we reuse those glyphs, so to speak, throughout the SVG constructs, and if you look into the actual output, if you inspect it, you'll see that there's lots of X-links going on. And is it X-links? I think, right?
Yeah, I think so.
Right?
Excellent. hrefs. Yep.
So that way, of course, you save space because you have your global object, like your font, and you just reuse it in the SVG. But that won't work when you actually export it in PDF. Or maybe it does. I don't know enough about PDF, to be honest. Do you know if you can do this?
So my understanding, when I generated the PDFs, was that the glyphs, or that the tools that I used did not support the X-link, so I ended up having to copy all the paths.
Right.
And so they got duplicated. PDF doesn't. Doesn't deduplicate.
Yeah, I would expect PDF not to be able to reuse paths.
Yeah.
Anyway, so. All right. Shall we ask for a round of questions, maybe? There's somebody in the audience.
There's one from Mark Grover that's oscillating up and down the list.
Oh, you see when I slide? Oh, I didn't know that. Sorry.
I don't know. It's been going up and down over time. He says it's about the poor degree of penetration when it comes to secondary public education.
Oh yeah, let's talk about that. That's a very interesting comment. Yeah.
So, he says, what I find intriguing, having watched the instructional technology increasingly approach a goal of transparency and universality, is the poor degree of penetration when it comes to secondary public education, let alone elementary education. So that must be a reference to open textbooks, which would be more Phil's kind of area.
Or it might have to do with numbers, but either way, I think it's a valid comment.
Well, for the numbers perspective, there are quite a few secondary teachers using it, and I think the reason for that might be that you don't need to get any software installed to run it, like things like MaplePA and stuff. You need to buy a license and get a server and have someone maintain it and that kind of thing, which I think is a lot harder in schools than in universities because they have much smaller IT infrastructure.
So what I've noticed from our little sprints with teachers is that teachers are extremely, or at least teachers in sciences, are very anxious to use free tools and are willing to incur some sort of learning cost to figuring out how to use the tools. And yeah, I think unfortunately it's a slow process to improve technology, to increase your target audience, and yeah, but it's happening slowly there.
Right. I mean, there is of course a question, this topic brings up one shortcoming of MathJax right now, which is the incompleteness of our MathML implementation, which of course we still plan to complete, but we haven't really had much time to work on it in the past year. And one of the big things is, of course, the elementary math tags that are specifically designed, were specifically introduced into MathML 3 to help elementary education, especially. So you have,
as an example, like long division, and
right.
Yeah,
You have long division notation. You have written addition and multiplication with carries and everything, and it's for us it's a bit difficult because we simply haven't had that much demand from people, and especially from our sponsors, which lies in the nature of things. They are mostly scientific publishers, so they rarely have a long division problem in their articles and so forth. But it is something that's important to us, and at the same time, it is an interesting, for me personally, it is an interesting problem. Whether, say, written multiplication, this kind of notation seems to be very much based on written communication, right? I mean, in written addition and multiplication, it's literally the handwriting that is recreated in the standard, which is a somewhat strange situation. Why do you really want to have different ways of striking through the carry, to indicate the carry and all these kind of things that are, but at the same time, these are, A, it's in the standard, B, it's obviously important for educational context. So, there's no doubt that we want to implement this, but it's. I have been wondering if there aren't more creative ways to solve the problem.
So actually, on the topic of elementary education, so we looked into helping to support or put in those types of features because some of our books that were coming out do have long division and other features in them. And the reason, maybe among others, but one of the reasons that we ended up not implementing not implementing it in MathML was that there's a clear separation between MathML and HTML. And so a lot of the annotations and bubbles with arrows that we wanted to put in weren't well defined in the math spec, but were well defined in other specs like SVG or HTML. So putting a picture of a dog, for example, next to the 2 that gets carried is impossible to do. But yeah.
Right. I think that's a very interesting problem. I remember at the accessibility sprint with Benetech earlier this year, there were elementary school publishers, textbook publishers there, and talking about how do you create accessible mathematical content. Their reaction was, well, our people draw these numbers, right? Because if you have a frilly 3 with made out of I don't know, grass or something, right? You don't do that in MathML, I guess, until Google gets its OpenType spec through to have colored fonts, because that's obviously the next technology we need. So sorry, I just read this again. I'm just so baffled by this. But going back to the topic, this is a problem, that we need to mix those two up. And I think for us at MathJax, it's really a natural step. In many ways, we are already ready for this because everything is modular, right? We have the input as being modular, we have the output as being modular, but actually the internal format is modular. And even though right now it's MathML, it can be extended. And we have actually seen people extend it. So the XYJAX extension that a Japanese developer has written in his spare time, that is actually working correctly, so to speak. As in, it really hooks into the internals of MathJax and expands the internal format to have SVG elements. And that way you can, mix those two. I mean, you can mix those two in MathJax easily, is what I'm trying to say. And for us, I think that's going to be important in the long run. If you see things like the Mathopedia folks, what they've done with implementing PS tricks by mixing SVG and MathJax.
Cool.
Yeah.
I did not know about that.
Yeah.
I did not know about the Japanese project of.
Right. Yeah. It's a really nice extension. It implements parts of the XYPIC package, which is a famous LaTeX package for drawing.
Okay.
And all right, I'm just seeing that Mark has been commenting on the thread. So I didn't not in the questions, but on the Hangout thread. So let me see. In case you want to read that, I don't know if you.
Where is that?
Yeah, it's in the. Let me put that into our internal chat. It's back on the Google Plus thread.
Okay.
The whatever it's called. The event item.
Okay.
I closed that thread because I have the feeling that it slows down my connection. I have this Hangout on air refreshing all the time. But this is, I think, also another thing where I would say, this is where MathML is MathML 3, because we haven't really, been able to move in that direction because MathML is still, in a certain sense, it is still very fresh. But from an HTML point of view, it entered HTML5, not HTML3 as it was supposed to, and so I think we're now seeing people expanding on these ideas. And it's going to be interesting. I think it's going to be very exciting to see how people really transform the way they communicate mathematics by expanding it in all the directions that the web offers. In interactivity and different strands of communication using different platforms and combining them. All the stuff that we've basically seen in the humanities, right? If you've seen history projects or literary projects that have just really transformed how they send their content, how they communicate by using several channels at once. We haven't really seen that for math and science yet.
Yep.
And eventually, and parts of it will feed back to the standard.
Okay.
All right. But I should mention one thing. I was just sort of mentioning one thing. Have you ever seen, because you mentioned it specifically, but David Carlisle, I think he's now head editor of MathML. He has written a sort of hack using MathJax and to do long division by using LaTeX syntax and then creating basically lots of LaTeX syntax. So it's a LaTeX macro and it creates lots of LaTeX that then gets converted into something by MathJax that looks like a long division.
No, I have not seen that.
It's a bit of a hack.
That's okay. My copy-paste is a bit of a hack as well.
Right.
Yeah.
I had some students writing some revision material for us over the summer. The idea was to cover sort of the transition from school to university, so they had to do some long division. And somehow they managed to write long divisions out using, I don't know, array environments and some hacks. So it looks quite nice that that they've got in the end. I think maybe if I'd been supervising them while they were doing it, I might have written the macro. But
it is tricky. I mean, the great thing about the MathML spec is that it's really complete, right? So but that of course makes it a challenge to implement. If you think about the elementary math elements, you have. I mean, the long division is an interesting example because it has all these variant stylings, right? So you have your US style, you have your continental European style, and you have all sorts of styles that go along with it. And it's I don't actually know how much the UK and the US differ in notational style. I do know that the German style and the US style differ, but I don't remember the UK, even though I studied math in the UK.
There are a few differences with the UK, but probably not as much. I think our main thing is the way we write the letter X, which I've in the past.
Right.
Go on for quite a while about the way people write X around the world. You're looking confused, Phil. In America, it's more common just to write a simple cross, like 2 lines that intersect. In the UK, we draw two curves back to back, so it doesn't look like a times symbol.
Oh.
Okay. And a while ago, I did a survey on Twitter, just asking people around the world, which way do you write it? And it seems pretty much the UK and its dependencies are unique in... Oh, and Russia write X that way. Everyone else just does a simple cross. And
that's the character X, just within the context of math? Or?
Yeah, just like a variable X, Y, Z. But, and then the French, of course, do something calligraphic and beautiful. But,
wow. Okay.
Yeah. It's terrible. There is this universal language and everybody uses it differently.
Absolutely.
All right, so I had hoped that... Oh, I'm sorry. You go ahead.
Oh, no, I was just saying it's presented differently, right? Currency separators and... yeah.
Right. Well, recently there was a discussion on the Math Working Group mailing list, and it was about basically right to left and how to, if you're working if you're working on the web and you want to have both LaTeX and LaTeX-like syntax and MathML, and you want to have directionality, how do you want to do this? Basically, the Viris people from this Barcelona startup that has a very nice math WYSIWYG editor, WIRIS, they're called.
Oh, that's used in Blackboard now.
Yes, it's the default in Blackboard 10. Yeah. They basically asked the question because they convert MathML into TeX, and so they wanted to know how to do directionality, and it's one of those things. It's quite surprising. It was quite surprising to me back when I first noticed that there's actually a lot of mix-up when it comes to directionality. So in the Arabic world, there are, you basically find all combinations of everything is right to left. Just the math is left to right, but then the textual elements are right to left, and it's very strange. And then the sort of the Latin elements in the math. So say an epsilon for element hood. That of course is left to right and not right to left, and it's just very confusing.
Oh my.
Yeah. Of course, as an expert pointed out, there is really just one type of directionality, but I mean 2 types of directionality, right to left and left to right, and you just sort of have to find the spot where you apply one or the other. But still, it might not be as easy when it comes to authoring something that should turn into proper MathML.
Right. Yeah. Theoretically solved, it's merely engineering.
Yes. As we know, that's so easy. All right, let me see if I can actually get our surprise visitor in, if he's around. So you guys have to talk because I'll be off trying to check.
Well, Mark's just posted something in the, I don't know what we call it, the comments thread on the event, giving the link to David Carlisle's hack to get long division going, which looks like it's something you were talking about.
Oh, cool. Thank you.
And yes, it does indeed do long division.
Oh, cool.
All right. Was that where? Oh, the link is in the thread.
Yeah.
I get that Google doesn't. I mean, it makes sense to have it separate because you don't want it to spam up the Q&A, obviously, and the Q&A doesn't do links, so there's really no other way to do this.
Oh, you're right. The Q&A does not do links. Weird.
Well, I can imagine if you're, some Hangout celebrity, if you're Barack Obama doing a Hangout, then you'll probably get a lot of weird content and multiples of that. But in our case, that's not so much of a problem.
I consider myself just as much a celebrity as.
It's good to know. I'll keep that in mind next time I see you. All right.
Oh, MathJax and ebooks. Yes, I would love to discuss that.
Oh, yes. That's a great idea.
Right, MathML is on the EPUB 3, right, spec, but no vendors that I know of so far do support it. And actually, probably Peter's would know which.
Right. So,
readers.
So I mean, the problem is, of course, that EPUB 3 is a little bit like HTML5. I mean, it is very much like HTML5 in that most of its spec is taken from HTML5. But it also suffers a little bit from the fact that, how can I say this? HTML seems to be developed in the type of, oh, we finished implementing HTML4, let's define HTML5, and then people start implementing it, right? So it suffers a little from the fact that browser engines don't fully support HTML5. So people have to work around it, and some do and some don't. And then with MathML, of course, you run into the problem that there is no browser or polyfill that supports MathML fully. There is Math Player as a plugin for Internet Explorer, for older Internet Explorers, but that's relatively limiting for an ebook platform. And Microsoft is kicking it out, being idiotic, so at least not very helpful. So the problem that I've been experiencing, or I've been seeing, is really that ebook reading systems are not willing to look into polyfills enough to implement the spec. In many ways, the Redium project is trying hard to change that by simply being the polyfill, if you will. The Redium Foundation, as it's now called, has this big SDK project, which is, I think, everybody expects it to replace the Adobe SDK for EPUB 2 that's sort of being used for EPUB 3 and doesn't really do enough. And so from our perspective, we've been trying to speak to reading systems and get them to implement things like MathML support via polyfills like MathJax, obviously. And they are not always listening. A lot of them just don't understand that they cannot wait for the browser vendors to get along, to come along and fix it. So that's a bit of a tough conversation. But there are systems that use it. And there are few, I admit, but there are big ones as well as small ones. So you have people like, for example, Ingram Vital Source, which is very book in the college book textbook market. They actually use MathJax on several platforms. There's Hazardi that uses MathJax in its web platform and in its mobile devices. And the Redium people we're working with, and we're hoping that they will use MathJax as much as they've used in the past. We helped them get it into the Chrome app back in the day. And then there are more. Oh yeah, the Ideal Reader is a great example. Ideal Reader is still very rough around the edges, but it's an interesting project. It's an Android application that is developed with an accessibility priority in mind. So screen reading abilities are built in. And the team were actually at the Google I/O this year, and they showed off the integration with Chromevox's math technology, which is actually part of Android. So they use MathJax to render, and then they actually leverage the fact that Chromevox via Android can actually hook into the MathJax output and speak the math. So those kind of things are happening. But at the same time, it's certainly not a good situation. You have to be very careful, and it's very frustrating, especially for large publishers who have to deal on a much larger scale of trying to develop content for every single platform out there. That's just not possible, and above all, Kindle is out of the picture because it just doesn't support MathML at all. It's not in the spec. And then there's the other side, which is if you have some reading systems, EPUB 3 has changed its attitude towards JavaScript. So where EPUB 2 said, forbid it completely, must not in the spec terms. The EPUB 3 spec had could or something, So you can, in an EPUB 3 reading system, you can allow scripting. Of course, not a lot of people do that, but when you have that, for example, in iBooks, then you can, of course, start trying to squeeze MathJax inside the EPUB file. And a lot of people have worked with that, and it does work surprisingly well. There are certain problems because, reading systems are kind of browser hell 2.0. You have your rendering engine, and then you have your reading system engine, and then you get in with your content. So you have to work around a lot of limitations. And for example, MathJax has problems detecting its fonts in that setting because iBooks will just not allow that to happen and break our detection mechanisms and so forth. And you get into problems with
that's interesting actually,
pagination
because
and so forth.
someone just posted to the numbers mailing list this week saying that she'd managed to put a numbers test inside iBooks using iBooks Author.
Right, iBooks Author is an interesting. So iBooks Author is something different, and I actually recently only at Books and Browsers I learned how different it is, because if you use iBooks Author, you will, on the one hand, not be creating an EPUB 3 file. You will create a proprietary extension of EPUB 3, basically. Second, you will not actually be using WebKit to render your content. iBooks, the reading system, actually comes with two rendering engines. WebKit, simply because of mobile Safari, which is used for EPUB files, and then they actually ship the Pages rendering engine, which apparently is significantly different. So it's worse than just the format. It's actually the rendering engines are different. So again, I have no idea what would happen to MathJax, but I know that it works. That you can, we've seen widgets by users, and it does work to get MathJax in there. And it might, for all I know, it might work better in iBooks Author. I've never really checked because it's our focus is on the open format.
I don't have any Apple devices, so I've got no way of checking. I'm going to have to track someone down who does.
And it might certainly, because it has such a big focus on scripted content, it might actually do things better. It might serve scripted content better than an EPUB 3 in a mobile Safari setting.
I'm going to have to go in a short while.
Right, yeah, sorry, I hope I answered. We never selected the question, but we were talking about this one, obviously. So thanks, Mark, for asking. I hope I could shed some light on that. But yeah, we're out of time, so I'm just going to say thank you. It was great having you.
Thanks for having me.
Yeah, it was a lot of fun.
All right, and thanks for our viewers and the good questions. All right, have a great weekend.
Take care.
Bye.